Hi all, this is Anand here. So last session we saw an introduction in C++. So today we are going to see the very important concept in C++ called the OOPs. So what do you mean by OOP? What is OOP actually? What is the full form of OOP? Object-oriented programming. That is called OOP. So that's a very important concept. NIOS Grade 12, Subject Computer Science, Chapter 30, Basic Concept of OOP. Okay. So what do you know actually? So some questions we'll see here. Can you tell me the difference between C and C++? C is what? Already this has been discussed. C is a procedural language, whereas C++ is an object-oriented language. That is the big difference between C and C++. What do you mean by procedural language? A language where programs are structured around functions that operate on shared data. It operates on functions. So C++ is what? Object-oriented, which operates on objects and classes. So you can see classes and objects there in the C++. So what issues arise when programs become very large and complex? So they become very difficult to manage, maintain, debug, and extend. So it will become very difficult if the programs are very large. So by the end of this lesson, you will learn the basic concepts of OOP and the various benefits of OOP and programming applications of OOP. You'll be learning at the end of this lesson. You'll be able to explain the programming applications of OOP. You will be able to describe the various benefits and you learn the basic concepts. Okay, let's start off with now with the real objects and classes like abstraction and encapsulation, modularity, inheritance, polymorphism. This is what we are going to see now. Let's go there and learn one by one with examples. We'll see that. All right. So let me go and sharing this. All right. So let's see. All right. Yeah. Now you can see object-oriented programming is a programming paradigm that organizes software design around objects rather than functions and logic. So you see the objects here that will be declared under the class. So object represent real world entities and contain data and methods. Data means it attributes, method means functions that operate on the data. You will see here. Okay, you will see everything you will learn here. Features of OOP. What are the features of OOP? It's an object. You will see these are the different features. This is what we are going to learn. This is main in C++. Object, class, data abstraction, data encapsulation, modularity, inheritance, polymorphism. These are the features of OOP. We are going to see one by one now. Let's see what is object and class. Let's see what are classes and objects. We'll see one by one now with a real term examples. Real world examples I'm going to give now. Because if you give examples with respect to C++, you might not understand. So I'll give, you see here, object. Object is what? A real world entity created from a class. For example, a car you drive is an object of the car class. A car, an object of the car class. You will see it. When I give examples, you will really come to know. Okay. So you will see that one by one. What is an object? What is a class? When we go through with it, you will come to know. Okay. Okay. What is a class? A blueprint or a template to create the object. You see here. Car is a class that defines properties like color, model, engine, right? So a car is a class. So to create objects. So car is a class that defines properties like color, model, engine. So we will be seeing all this now. Class, you will declare a class, you will declare an object, and how it works, you will definitely know when I'm teaching you with examples. Abstraction, data abstraction. You have to know what is data abstraction now. Data abstraction is nothing but showing only the essential details, hiding the complexity. only the essential details will be shown. The complexity will be hidden. For example, if you use the ATM, you'll see the options like withdraw or deposit. You will not know how the transactions work internally. We need not know that. But you will see the options like withdraw and deposit. So showing only the essential details while hiding the complexity. This is called data abstraction. You should understand what is abstraction. Data encapsulation is very important here. You see data encapsulation. See, data encapsulation is binding and data and methods together while restricting direct access. You will not be able to access the data and methods directly, but you will bind the data and methods together. For example, a capsule hides its medicine. Right? Its medicine, a capsule, no, that it will inside it will have the medicine. Capsule will hide its medicine. Similarly, your bank account data is hidden, but access through methods like deposit and withdraw. Right? See, I'm giving a real-time example, so you can easily understand this. So next is what? Modularity. Breaking a program into independent modules, smaller modules. That is called modularity for easy management. Breaking a program into independent modules. A car has separate modules like engine, brake, music system. Right? You break the system into different modules. So car can be, say you have an engine, you have a brake, you have something else. So all the things put together will give you a car, a full car. So I'm just giving some examples like engines and brakes. You can have other examples also. You can have other systems also here, right? Breaking a program into independent modules for easy management is called modularity. You have to understand. Next is inheritance. Very important is inheritance. Inheritance is what? Inheriting the properties of the parent class. A child inheriting the properties of the parent class. A class acquiring the properties and behavior of another class. So the class which inherits the properties of other class is called the derived class. And the other class is called the base class or the parent class. See, the electric car inherits the features of the car class. So car class is called the base class. Electric car is called the derived class. Right? So car class, you have to the main, that is the main parent class. But electrical car, what is the attribute? You can add an attribute called battery. Battery is a functionality for electric car. Right? So electric car inherits the features of the car, but has its own functions. I derived the properties of my father because and also I have my own functions. Right? So that is called inheritance. Next is polymorphism. Okay. Polymorphism is what? So a method behaving differently in different situations. For example, a brake function will work differently for a cycle. For a car, it works different. For an aeroplane, it works different. But brake is a common function. But it works different for a cycle, for a car, for an aeroplane. So a method which will be different will have the same name. A method will have the same name, but it depends on the different situations how you call it. So let us see one by one of what are the like cars, and we'll see examples one by one. Let's take the first example. Let's take the first class, objects. You see here, instance of a class representing real world entities. See the same program we have seen in the previous session. You will have IO stream, you will have using namespace, you will have an int main. All these things are there. Class student, we are declaring the class. And name is an attribute. Display is a function. Void display means it will not return any value. If you give a return in the function, it will be a return int or float will be there. Since you are not returning anything, it's a void. So void display is the method name is the attribute. So that is public. Public means it can be accessed from the other classes. That is why it's declared as public. If it's declared as private, it cannot be accessible by the other objects. So that is very important. So now I am declaring a class student. Now inside the main, what I am doing, I am assigning an object S for the class student S. So from the S, I'm going to call the display and the name. right? S dot name. I'm going to access the name and the display using the object yes, which is declared as a class student. You're declaring the object with the class student. So student s dot name is equal to John, s dot display. So name will be declared as John and that will be printed. So this is the meaning of this. This is how you have to access the object. So very simple. So let me run this program there. Wait a minute. Okay. Just modifying a program here. That's right. Okay. So let me share it now. I hope you are able to see this JGrass. See, I have copied pasted the program there. So now what I'm doing, I'm compiling it. Yes, it has successfully compiled. And now you see that the name is John. So the variable is taking the name as John. The variable, right? So how do you declare it? Class name followed by the variable name. Class name followed by the object name. Object name is yes. So yet you are accessing the objects of the, you are accessing the attributes and functions of the class through the object, right? So s dot name is John, s dot display. So you see there, it is being displayed. So I'm calling the function. S dot name is you call the function, display from the main method. So it will call the function, name is declared as John. So it will print name John. Okay, next we'll see. So what does it do? This program creates a student class with the name, attribute, and display function, and then uses an object yes to store and print the name John. You have to know this, right? That is very important. Next is what? Let's see the next one. Classes. Yeah, it's a blueprint to create object. Same thing. So we are seeing it now. So I'm running it. Let me share it first and then show you the program actually. You see, this is the class. I'm declaring same program. Next program, I'm doing it. You see here, car is a class. It is having an attribute model and a function show, which is a non-returnable void. So both are public. So what I do in the int main, I declare the object C with a class car followed by the object name C. So I am accessing the model and the show of the car class through the object C. C.model is Telsa and dot show. So it will print model and it will give the name of the model. Let's see. Let's use this JGrass to run it. Yeah. Now you see successfully executed. Now I'm running it. You see model Telsa. Very simple. So you should know first you have to declare the class. Inside the class, you should have the members. Then you have to start. You can have another class also. Then you have to start with main. Then give the class name followed by the object name. So call the attributes. You have to access the attributes and the methods you can access through the object, right? So you should know this very well. So next is what? Next we have, so this program does what? It defines a class with a model, attribute, and show function, then uses an object C to set and display the model Telsa. That is the meaning. Next is data abstraction. Let me show you the program. Yeah. Let me share it and show it to you. Then I'll run the program. You see here data abstraction is shown. Data abstraction means what? I told you already. It is meaning hiding details. It hides the details and showing the essential info. Showing the essential info, but what? But hides the implementation details. Let's see what is that. So it has the class. It is having a bank account. Is the name of the class. It is having the members balance and the method name is the deposit and the get balance. Get balance and deposit is what? They are the methods or the functions. So you pass the parameter. For the deposit, you pass the parameter as an amount. For get balance, you are not passing any parameters. You are just returning the balance. You are printing the balance. You are returning the balance and then printing it. Then balance. You calculate the balance using the deposit function. Where you calculate the balance using the deposit function. For that, you pass the amount to the method balance deposit. So in the main, you can see that I am declaring the object account ACC with a class name bank account. Through the object ACC, you are accessing the member dot deposit, right? Dot deposit of 1000, which means what? You're accessing the function which takes the amount as 1000, right? So now what it does, it goes and then it will get balance. I'm accessing the function get balance through the object. So it will go, you know that balance is what? Balance is 0 currently. So balance plus the amount plus 1000. So you will get the balance as 1000. So internal details are hidden. Details, you are just getting the balance, right? So what does this program do? The program shows abstraction by hiding the internal balance. Internal balance is being hidden, allowing the access only through deposit and get balance methods. Let's run this program using the JGrasp. Okay. So now I'm running this. Let me run this and show, and let me run the abstraction. You see now? So I'm running the program. So I'm compiling it and then I'm running it. Balance 1000. First, what happens? Deposit is called through the object. So deposit is done what? So a deposit is that deposit is calculating the balance. Balance is 0. So it will calculate because you are declaring the balance. When you declare it, it is taken as 0. So 0 plus amount. Amount is sent as 1000. So it will calculate the balance as 1000. Next line, you are printing the balance. Account dot you are calling the get balance through the object ACC, right? So it will print the balance. So this is what is abstraction. So next, we'll see encapsulation. Let's see that. Okay, let's see the encapsulation program. Wait a minute. So encapsulation is what? Restricting direct access to some members and controlling it through some methods. You're restricting some direct access to methods or attributes, and you're controlling it through other methods or variables or members. So we'll see what is that. Wait a minute. Yes. Now you can see the data encapsulation. So data encapsulation, combining data and functions into a single unit. So into a single unit I'm combining, right? Box is a class which is having the data member length, and it is having two methods, set length, where the length is sent as a parameter, and I'm setting the value of length as L. So you are not accessing the length. You're not accessing the length, right? You are passing the parameters and then storing it in the variable length. So get length will return the length. So now inside the main, you are assigning the object through the class box. B is the object. So B dot set length. So it will set the length. What is the length? What is length set? 10. So length will be taken as 10, and then using the get length, you are accessing the get length using the object B. So get length means you are returning the length, which is 10. So I'm not printing any length here. You see here in the main, I'm not writing any length. I'm not giving it. It is accessed through the methods. It is accessed through the methods. I'm not directly accessing the length in the main function. You can see that. So this is called encapsulation. Next is modularity. You divide the programs into independent modules. So which I will show you now. Yeah, wait a minute. Yeah, modularity. You see, dividing programs into independent modules. See, I'm going to create a method, right? I'm going to create a class which is having a method called add, which returns the sum of the two variables which is sent as parameters. So now what I do is I call this function add through the object in the main. So math OPS is the class with which I'm creating the object M. So M will call the function add. What is add doing? You are sending the parameters 5 and 3. 5 and 3 are the values of A and B respectively. So it is sent as the parameters to add function. So now 5 and 3 will be added and will be returned and sent to the main. So sum is equal. So you're dividing it into methods, into program segments. So you can have subtract, you can have other method, divide, you can have, and you divide it as separate segments and then you call it. So what you do is you divide it into independent modules so that it will be easy, modularity. So that is the main feature of the C++. So this program demonstrates modularity by separating the addition program into math class. So math OPS class, making the code organized and reusable. You can again and again call the add function. Otherwise, you have to again and again write the add into the main function. No, instead of that, you just call the add inside the program. You can do that. Okay, next is what? Let me run this program in the JGRASP and see what is happening. I have already copied it. I have already copied this math OPS there. You can see the program there. So now what I do, I execute this program. It is successfully executed. Now I run this program. You see, sum is 8. Very simple. So next is what? Next is inheritance. Very important. Inheritance. Okay. Inheritance is what? Inherit the features of the parent. Derived class inherits the features of the parent class. So how do you declare? First, you declare a class called animal. Animal is the base class, parent class. In the parent class, you have a sound. Because for every animal, there will be a sound. But what is the sound of a dog? What is the sound of a cat? What is the sound of an elephant? Will vary. So what you do, you take a dog as the derived class, which inherits the properties of the base class. Because sound is the general sound. But dog has a sound called bark. Right? Oh, 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 oh. So that is the sound. So when you call the dog, when you have the dog class, the sound is bark. Dog barks. When I have the cat, you will have cat mews. Right? A lion roars. So basic is sound, but you will have the separate sounds for the derived classes. So animal is the base class, dog is the derived class. So now what happens? Now in the base class, I'm going to this sound is an attribute which is a public. It's a data function. It's a function. Sound is a function which is non-returnable because it doesn't return any value. That's why it is called void. It's a public. So it is now the animal classes being declared on the top. Now coming down, I have the class dog colon public animal, means you can inherit all the methods from the base class. That is why it is declared as public. Private means you cannot access through the objects. If you declare it as public, the objects you can access the variables and methods of the public class. I mean the public members, right? Now you see what I'm doing in the main. I declare the dog. Dog is the base class. The base class followed by the object D. D is the dog. If you want a cat, you can say cat C. You can give. So after that, you can give another class cat colon public animal. So it takes the features of the animal class, extend the features of the animal. So public sound. You see now D dot sound means what? It will not take the sound of the animal. It takes the sound of the dog because you're calling the dog function. Dog, you're calling the dog class. You're not taking the animal class. So dog D dot sound. So what output you will get? Dog barks. You will get the output. Let's see now. So what does it do? Now this program demonstrates inheritance as dog inherits from animal and override sound to provide its own behavior. What do you mean by override? Override means both the animal class function and the derived class function, the method name will be the same. Both are having the sound, but child function is called. It will not be the base class function will not be called, because I am creating an object on the child class, not the base class. Okay, so that is called override. Override means it will override the child class. Okay, dog inherits from the animal and overrides the sound. It will call the function of the derived class. So what I'm doing, I'm creating an object on the derived class and calling the function sound. So dog barks will be the output. Let's do it in the in the J graphs. Let's see that. Wait, yeah. So I am just going here. I am pasting the program here. So you know that now you see what happens. I execute this program and I run this program. That's it. Very simple. You can again, I have another class. You see here, I can have a class. I can have a class cat. And the inheritance, what does it? Derived class is what? Base class is what? Animal. That's our the cat news. Now I have cat C. I'm just giving some name. Slash n means a line is left. That's why I'm giving this slash. Okay. Now when I run dog box cat news. Very simple. Right? Okay. Let's see the last one, which is polymorphism. Polymorphism means taking many forms. Right? Taking multiple forms. One interface taking multiple forms. It's called function overriding. Okay, let's see what is that. Okay, wait a minute. Sorry for that. I just copied here. Okay, let me share it. Polymorphism. Wait a minute. Yeah. So let me share it now. So you see polymorphism means, you see, I have a class called shape, and the shape is having two methods with the same name. So that is what is called having many forms, but depends on what you call. Suppose inside the area you have two functions with one function having one parameter, the other function is having two parameters. So if you call the particular function with one parameter, so the first function is called. If you use two parameters, the second function is called. So the first function is for the area of square, the second area is for the area of rectangle. Let's see. Down you see. So I declare the object yes with the class shape. So yes dot area of 5 means you are passing one parameter. So the first function is called area of inch side. So side times side will give 25. Suppose if you say yes dot area 4,4.6 means it will call the rectangle's area, which is length times width. 4 times 6 is 24. So you will get the output for the area of square 25 and area of rectangle as 24. Let's see that whether we are getting. We'll use the JGraphs and copy the function. Okay, let me copy this program. Yeah, now I'm pasting it. Now you see the program is being copied. Right? Now what I do, I execute it. I compile it. Now I execute. You see area, it will give area of square, and area of square will be 25. Area of rectangle will be 24. You see here? So very simple. This is called polymorphism, taking many forms. Right? So this is actually the polymorphism. Now we see what are the benefits. So let's learn it there. So we have completed the features of all the features, encapsulation, polymorphism, inheritance, modularity, everything we have seen now. Now we are going to see the benefits of OOP. What are the benefits of OOP? Manages complexity, reusability of code, easier maintenance, enhanced security, scalability. These are all the more benefits. Advantages of OOP. We have already seen the objectives of OOP. Those are the benefits, right? Complexity, it will manage easily. Your reusability is you use the code, reusability of the code through classes and inheritance. Easier maintenance. Maintenance is easier. Security is enhanced via data hiding, right? Scalability. New features can be added with minimum changes. So these are all the benefits of OOP. Okay. Now we see what are the programming applications. So these are all the programming applications you can see. The program, what are the programming applications? So operating system and GUI, you can control this operating systems and GUI. You can use the C++ for business and applications. You can use C++ for simulations and modeling, right? For the, the object-oriented programming of C++. So these are all the different applications. Yeah, you are using it for artificial intelligence and expert systems. You can use it for CAD/CAM software. You can use it for object-oriented databases. These are the programming applications of OOP. Okay, so these are all very important. We have seen actually. Let's come into our presentation. So now let's go for some questions. So what type of language is C++? It's an object-oriented programming language. You have to know. What is encapsulation? Encapsulation, I told you, it's the wrapping of data and functions into a single unit with controlled access. You're wrapping the data and functions into a single unit, right? Or a class. C will run under what compiler? C can run in C++ compiler. It can run in C++ compiler. A derived class can be derived from what class? A derived class can be derived from base class or the parent class. You have to know this. Okay. Next, what we learned? We learned the objects and our classes. We learned the abstraction and encapsulation. We have learned the modularity. What you're splitting the program into sub-programs, right? So modularity. Then after that will be the inheritance and polymorphism. This is all what we have learned. So check your understanding. What are the functions of OOP? Again, what are the functions of OOP? Functions of OOP are what? Features of OOP, sorry. Features of OOP are what? Objects, classes, data abstraction. Then you will have encapsulation, modularity, inheritance, polymorphism. These are all the features of OOP. Then explain briefly all this. Data abstraction is what? Showing essential features while hiding implementation details. Showing essential details while hiding implementation details. What is data encapsulation? Binding the data and functions into a single unit class to secure data. What is polymorphism? Allowing the same function or operation to behave differently based on context. So a method having different forms, right? Many forms. Okay, inheritance. What is inheritance? Inheritance is nothing but creating new classes from existing ones to promote code reusability, right? So that is inheritance means inheritance is what? The class which inherits the properties of the base class, right? That is inheritance. That is very important. So describe the benefits of OOP. What are the benefits of OOP? Creating new class from benefits of OOP are what? Manages complexity, then support modularity, enables reusability, then simplifies maintenance and improves productivity. These are all the benefits of OOP. Okay, we have seen the benefits of basic concepts of OOP today. So next video will be seeing on control statements like if conditions and looping statements. Conditional statements and looping statements will be seeing the next session. For now, we are closing the session, video session. We'll meet in the next session. Thank you. Have a nice day. Bye-bye.